Welcome to another interesting DSA problem which is titled as reverse linked list. So let's try to understand what is a problem statement. You will be given a linked list and you will be also given a pointer head that denotes the starting point of the linked list. What you are supposed to do is that you need to reverse that linked list. How can we do that? You don't need to swap the nodes from the starting to the ending point and the ending point to the starting point. You don't need to do that. What simply you can do is that whatever be the direction of the pointers at the existing condition, you just need to reverse that. For example, if one is pointer from node value 1 to node value 2 is like this, you just need to reverse it and assign it to none. Similarly, 2 to 1, reverse it, 4 to 3, reverse it, and assign head to the endpoint. This will itself will reverse the linked list. This is equivalent to writing 5, 4 pointing to 3 pointing to 2 pointing to 1 pointing to none. How can we do that? What we can do is that let's start by accessing. I think it's better to write the code and explain it side by side because it's a straightforward approach. Okay, so class solution, this is the method inside the class. There's nothing but reverse list. What are the arguments? Self, then head is given, which is nothing but optional list node, then you need to return another optional list node. Let's start from a variable which is previous, initially accessed or assigned as none, and the current equal to head. So what in this particular step we did is that we used a variable to store none and we assigned another pointer, as you can see in the orange letters, current is nothing but another pointer. Right now it is where the head it is. Okay, now we are going to iterate current while current. I am going to use another pointer temp, which is nothing but current dot next. So temp will be here, and then what I am going to do is that current dot next is nothing but this pointer, which the highlighted pointer. Okay, I am not going to assign it to 2 anymore. What I am going to do, current dot next I will be assigned to previous here is nothing but none. So this pointer, okay, will changes and assign to none. As you can see here, it will point to none now. Then what I am going to do is that the previous, currently it is none, the previous would become current. That is nothing but this node 1. Previous become this thing. Okay, I am going to write it here. This becomes previous, and then the current became temp. So the current now gets an updation. Current becomes temp like this. And in the next iteration, the temp became current dot next. This is current, okay. And the next iteration, the temp became current dot next. So the temp will also get updation. And again the current dot next will be assigned this pointer, okay, whereas this pointer will be updated or point to previous, that's nothing but this node. So this pointer will change us to this pointer like this. So that's what happening here. And again the previous will get updation to current, and the current will get updation to the where temp is there, and the temp will get updation to current dot next. Like this it will keep on going until there is no current. Like when the current is none, here this will terminate. And imagine the orientation of this pointers. There is a pointer previous, there is a pointer current, there is a pointer temp. If the current pointer is at this location none, this will get terminated. By the time every pointers would have been like altered, or it became in the opposite direction. So imagine what would be the pointer that is going to denote the end node, like what will be the head. As you can see, if the current is here, previous is one step below. So at this location, previous would be the one standing. So we need to return the head. Here head is nothing but the previous pointer. So once this iteration is over, what we need to do is that we need to return the pointer previous. So once this pointer previous is returned, as per the test cases, we can check whether this linked list is reversed in the correct order or not. That's what this problem statement trying to do. So what is the time complexity of this problem? Since we are iterating through one and remaining, the game is all about like putting the pointers at the appropriate places and doing the jump whatever is necessary. So we are just iterating it once through the linked list. So the time complexity is order of n. We are not utilizing any extra list. So the space complexity is order of 1. And I hope you understood the problem of reversing linked list. We can also try to approach an updated version of this problem, that would be reverse linked list part 2. I hope you understood, and thank you for listening.